There are objects in our universe that feel so extreme that they almost feel fictional. And neutron stars are certainly one of them. I'm Jason, and this is Through the Bulk, where curiosity talks back. And today, I want you to imagine a star, much larger than our sun, living out its life for millions of years, fusing atoms together, shining quietly in the darkness. But eventually, it runs out of fuel. And when it dies, it doesn't simply fade away. It collapses violently. In a supernova explosion so powerful, it can briefly outshine an entire galaxy. Now what's left behind is something almost impossible, a neutron star. So take the mass of our sun, about 200,000 Earths, and then crush it into a sphere that's roughly 12 miles across. A city-sized object containing the mass of a large star. The result is so dense that atoms themselves can't survive. Electrons and neutrons are squeezed together, merging into neutrons. The entire star essentially becomes a single gigantic atomic nucleus. The density is really difficult to comprehend. A teaspoon of neutron star material would weigh about 1 billion tons. I mean, that's roughly the mass of a mountain, sitting in your kitchen spoon. And the weirdness doesn't stop there. Neutron stars spin. When the original star collapsed, conservation of angular momentum took over, like an ice skater when they pull in their arms. But this skater is now the size of a city. Some neutron stars spin as fast as hundreds of times per second, and their magnetic fields, which are already immense, become twisted and amplified to a degree in which they are the strongest magnetic fields known in the entire universe. Now, these are called magnetars, and their magnetism is so powerful that if one passed halfway between the Earth and the Moon, it could erase every hard drive and credit card on the entire planet. And neutron stars are cosmic lighthouses. As they spin, beams of radiation sweep across space. And when those beams pass Earth, we see them as pulses and perfectly timed. We call these pulsars, and some are so precise they rival atomic clocks with their accuracy. And yet, beneath all of this violence and physics, there is something strangely beautiful about them. They're what happens when gravity pushes matter to the very edge of what reality allows. Although immensely stable, they exist right on that line, just before gravity collapses into the singularity known as a black hole. They are the universe experimenting with the limits of existence itself. And neutron stars are a reminder that the universe isn't just big, it's absolutely astonishing.